to conduct a simple linear regression analysis. Simple linear regression because it's only two variables we're going to be using, an explanatory and a response. We need to import the data. So that's one of the ways of doing it. We're going to import a data set. So we're going to import data set. We click on that and we're going to import from Excel. And we go to browse. You go to browse and you look for it. Well, it's on the desktop. Let's search for it on the desktop. And it's in practicing RStudio. So let's look for practicing RStudio. That's where it was located in this device. And its name is RD. So we click on RD, we click on open, and we click on import. And here it is. Here it is imported into RStudio, the data set. Positive, math feelings, and score. So positive math feelings will be the explanatory variable, and mathematics score will be the response variable. So first and foremost, we're going to plot a scatter plot. So we need the code for that. Here, you can simply type plot and the name of the data set, which is RD, the $sign, and the explanatory variable, which is pos, representing positive math feelings, comma, the data set again, RD, the name of, thereof, and the $sign, and the response variable score, close bracket. So this is already typed, so we can copy and paste in RStudio. So we're going to paste it in RStudio here and click enter. So here is the scatter plot of positive math feelings versus score, or score versus positive math feelings, the y variable, then the x variable. And here's the scatter plot. So we are going to perform two adjustments on the scatter plot. First, we're going to give it a title. And second, we're going to change the name of the variables. So here, we copy and paste plot RD, $sign positive, comma, RD, $sign score, comma. And to give you title, you type main equal, and in quotation marks, you put scatter plot of motivation versus, well, it's not motivation, it's positive math feelings. Okay, so let's edit this, positive math feelings versus mathematics score. Positive math feelings versus mathematics score or math score. So that will be the title. Now, the X label, let's put it as positive math feelings, and you put that X label equal sign, and you put positive math feelings in quotation marks, comma, Y label or Y label equal sign. In quotation marks, you put math score. So that will change that will insert the title, and it will edit the labels for the X and the Y variables. So we can just copy this, but look at this carefully and you can type it out as is. And then you paste it in RStudio in the console and you click enter. And as you can see, the X variable and the Y variable, they are both edited as indicated in this code. And the label is scatter plot of positive feelings versus math score. So we're going to proceed with the analysis. We are going to do a summary of the linear model. So we're going to create a new variable. Let's call it LR for linear regression. So you can call it anything you want. Or you can call it line, linear regression. You can even call it model. Here I just call it LR. And then you put your left arrow and your dash and you type LM or linear model, and in brackets, you put the y variable first, which is score, and this sign, and the positive, that will be the explanatory variable. So when you're doing this, make sure you put the response variable followed by the explanatory variable after you put the sign. You call up the data, the name of the data that you are going to use, that the data is equal to RD. And this will create a new variable called LR. So look at this very carefully to create a new variable in R Studio. So we copy this, Control C, and in R Studio we paste it and we type enter. So as you can see, here it is, a new label has been, a new variable has been created called LR. Okay, and we can go now to our coding and we can call up a summary for LR. So there are different things we can do with that new variable, which is the linear model. So you can find a summary of it. So just type summary in parentheses LR, and you Control V, Control C, Control V, and here it produces a summary of the linear model. All right, the formula, here it is, LM, RD, data. You have the minimum, the max, the median, the maximum value. Here you have the coefficients. So this will be the y-intercept, 47.2162 and 0.5229. That will be the slope, okay, of the linear model. And you have the f-test, a p-value of 0.000381, which shows a level of significance with this linear model. With this new variable created called LR, a lot of things can be done apart from the summary. We can call up the coefficients of LR. Let's do that. Control C, Control V. And here you have the coefficients. As we say, the y-intercept, that's where the regression line will touch the y-axis at 47.22, 47.216, and the slope, the gradient, 0.5229. Okay, that would be the rise, the increase in math score with every unit increase of the positive math feelings. So every time the positive math feelings increase by 1, the math score increases by 0.5229. So we call that the coefficients of the linear model. Also, the coefficient correlation between math score and positive math feelings can also be calculated by just typing COEF and in parentheses put the variable created LR, copy this, or you can type it directly in R Studio and you click enter, and here that's another way to get the y-intercept and the slope, but we're going to look at how to get the coefficient correlation. So a little research says that the Pearson correlation is computed by default with the COR function. Okay, so here you have COR, open brackets, and you put the data, and you can put method equals Spearman. But if you don't put the method, then it automatically uses Spearman. And it automatically uses Pearson, sorry. Okay, but if you want to use Spearman, you specify Spearman. However, we have already created a new variable with those two explanatory and response variables. So I'm going to try something. We're going to use COR, and in brackets, we're going to put the parenthesis. In parentheses, we're going to put LR, the function, the variable. So let's see what happens if it will generate the coefficient correlation of Pearson's. Because we have already created a new variable. Oh, it says an error. So we must type in. I'm going to type it in as is like this. And then we're going to try it again. So as you can see, I'm going to type it as it is there. COR for correlation, open. Okay, so here it appears. Put COR and locate there, right? COR, and it bracket appears. The data is RD. That's my name of my data set. So I'm going to put RD there. And then we are going to put the $sign. Okay, and it is asking for what variable to put. We're going to put the X variable first. So I have the positive mass feelings. So all I can do is to copy and paste RD and the $sign. We put the comma. And then let me just put the $sign so we can activate. And we put the response variable score. And then we just come out from parentheses and we type enter. So let's see what happens. Right, so the coefficient correlation, according to the Pearson's coefficient correlation, is 0.61. So every little disappointment is a blessing. So as you can see, we can actually calculate the coefficient correlation. So there's a strong positive correlation between positive math feelings and score according to this result. So very importantly, we can also construct the line of best fit, the regression equation line. Okay, we can use AB line, A for the y-intercept, B for the slope, AB line, that's it, AB, the regression line function itself, the line itself, and we're going to use that variable we have created, LR. So let's see what happens. So you type AB line, and in parentheses, you put the name of the variable that you have created, and let's see if it will generate the regression line. You must put AB line, and in parentheses, put the variable that you created, the linear model variable that you created initially. So let's go to our studio. Click enter. And here it is, voila, the linear regression line. And you can see it has a positive slope. And according to the result, every time the positive math feelings increase by 1, the mathematics score increases by 0.5229. So this line shows you the behavior of the math score. So you can see the math score is increasing as the positive math feelings increases.